What an honor to be last activity before lunch. Thank you to all 5 of you. I really appreciate your interest in this topic. So I'll tell you basically about my research, about what I do and why I do it. I'll try to do it quickly. So we all know about 2023, a new model was released, revolutionized the world, changed everything. And it was the first time in AI history where we had something general, showing sparks of generality. It wasn't a narrow model just for playing chess or just for driving a car. It was doing really well in many different domains, and it was kind of capable of learning new skills. It did well on college exams, medical, law exams, and overall, it was capable of scaling. What does that mean? For the first time, we had an architecture where you didn't need a major breakthrough every time to do something interesting. You could just add more compute, add more data, and it magically started doing more things and being more capable. So we were kind of building on what Ray Kurzweil did with his prediction curves, and it was essentially a moment where people realized we can switch from asking how long before human level, how long before AGI, to how much. If I can buy enough compute, enough resources, I can probably get to that point much, much sooner. So the first question I always get is, of course, how long before AGI? I don't make my own predictions. I look at prediction markets. They change. The screen grab is probably somewhat older now, but something around 2027 is what prediction markets have been saying for a while, maybe early 2028. And likewise, leaders of the top labs on record as saying we are probably 2-3 years away from AGI in a traditional sense. Of course, what we have today already, if we showed it to a scientist from the 90s, computer scientist from the 90s, they would agree that what we have is AGI. So it's a bit of a spectrum. We have maybe weak AGI, and we are working very hard on building a more general system, which eventually will be able to do science and engineering for us, including working on creating next generation of artificially intelligent systems. So it sounds awesome. Lots of people get excited about it. We'll get free labor, physical, cognitive. We'll cure all diseases. We'll cure aging. We'll get lots of great things. In fact, we'll get some unknown unknowns. Things so good and so awesome, I can't even predict what they are because I'm not super intelligent. Unfortunately, that's the last positive slide I have, because for every one of those awesome positive things, there is a complementary negative thing, a problem. With robotics come military robots, with free labor comes technological unemployment, and again, we see the unknown unknowns. Problems, really big, bad problems we cannot predict because we are not super intelligent, and so we can't really well prepare for those problems. The good news is there is a lot of big, important, famous people who are now taking this problem seriously, including a lot of scientists, a lot of Turing Award winners, Nobel Prize winners, scientists in general who are working in machine learning at top conferences, who are equating dangers from advanced AI, advanced intelligence, to nuclear war, meaning existential risk level problems, and they are strongly advising us to maybe not rush as fast as possible into building general superintelligence. Oh, I just realized we'll have Wozniak here. This is good. So what I do in my research, we started with first understanding what type of problems we are facing and at what stage. Is it at pre-training stage? Is it at deployment? Is it sort of standard problems we see with software? Programming errors, design mistakes? Is it problems with data? Is it all the standard classical issues? And what makes this set of problems unique is that there is also malevolent design possibility. You can have someone who is either compromised, blackmailed, insider threat in a company, who's trying to add a malevolent payload on purpose to the system. So at all stages, for many different reasons, we're likely to have problems. And some of those, if they're man-made, man-caused, we can understand. We can understand motivation behind those and maybe deal with the human behind the problem. But the concern is, of course, independent systems, agent-like systems, which set their own goals and maybe beyond our capacity to understand and comprehend what they do. We wanted to know what are the options, what can we do to solve this problem of control. First thing we did, and this is pretty long time ago by modern standards, we surveyed everything people suggested in literature and books, everything we could find in terms of how can we control intelligent machines. We surveyed maybe 300 different sources. We grouped this information by classes, by types. I don't have time to give you all the details for each one of those. I'll give some general examples. But I really like the one from the bottom there, 1863. Somebody said, you know, machines are really getting out of hand. We need to start controlling them. I found it really adorable. So what is this problem we're trying to solve? The first 50 years in AI, nothing really worked really well, and people talked about encoding different human ethics into the system. Everyone had their own flavor of ethics. Everyone tried named ethics after themselves, their religion, and that was really the approach. About 10 years ago, things started to work, and people realized ethics is not going to get us there. We need safety. We need to make sure the systems behave well. And so you see the change in naming. We started talking about creating friendly AI, control problem, human-friendly AI, human-compatible AI, my favorite, AI safety and security. But essentially, the problem is, how do we create something so powerful, so intelligent, and don't regret doing it? How do we make sure the outcome is beneficial to us? And this is essentially the problem we are working on. It is early. We don't even agree on a true definition of a problem, and people sometimes would argue that there is no problem. So lots of work to do. And in computer science, we typically start by trying to understand the type of a problem we're dealing with. How computationally challenging is it? Is it solvable? Is it NP-complete? Is it even meaningful to ask a question about the nature of this problem? And for this problem, at least outside of my research, there is no definitive answers for it. People disagree on how difficult that problem actually is. So here I have a small collection of different types of experts. I have Geoffrey Hinton, who is the grandfather, godfather, whatever relationship he has to machine learning, who got Nobel Prize and Turing Award for his work on it. We have an outsider recognized for his work on AI safety, and we have, at the time, director of one of the top AI safety labs. And the spread of opinions is the problem is somewhere from super easy to solve to I have no idea, and the no idea is the godfather of machine learning. So we don't have an agreement, we don't have consensus on the difficulty of a problem. So far, we know that no one has proposed a definitive solution accepted by everyone, peer-reviewed, patented, published in any way whatsoever. And so in my research, I want to study the problem a little deeper, try to understand what is the state of a problem, and try to understand what we can do in order to address it. The way I see it is, if I'm going to control an advanced agent, I need to have a set of tools. I need to be able to do certain things, maybe explain how it works, predict its behavior, comprehend explanations about the internal states of a system. I should be able to verify its behavior, code, related components of a system. Maybe some other tools. Maybe I don't need all of them. Maybe I can use one tool instead of the other, but this is the general idea we were working on for a while now. And so each one of those is a published result, usually a journal paper or conference paper in computer science. They're about equal. And so we found that there are strict limits on what can be done in this space. In terms of explaining or comprehending advanced AI, there are strict limits on how much we can understand. The models are getting larger. We're talking about billions of nodes, trillions of weights, parameters, whatever you want to call it. And so ability of a human mind to survey and comprehend something so complex is limited. We are well above that capacity. The alternative is to have some sort of a reduction in size, give you a compressed explanation. So if you ask, what is the reason my loan was denied? The system can give you top 10 contributing factors to that decision. It's not a full explanation. The full explanation is the model itself with all the weights. You cannot comprehend it. But the simplified explanation allows for smuggling of problematic decisions into the process. So there are strict upper limits on our ability to comprehend those systems. Most people think that people designing, making those systems know how they work. It is not true. They do not, we do not. It is mostly a process of growing it, kind of like growing a plant, growing an animal, and then studying it to see what it's capable of doing. Another limiting result is our ability to predict those systems. We can predict general direction. If I play chess with an advanced AI engine, I know I'm going to lose the game. I cannot predict specific moves that system is going to make. And how do we prove that? Well, if you could, you would be playing at that level. You would be equally super intelligent player, and we know that assumption is not true, neither theoretically nor based on actual practical games. There are also limits to verifying mathematical proofs in software. We have some rudimentary ability to verify mission-critical functions. Very important software can be verified to match the design. So implementation, the code matches software design. We don't know how to verify dynamically changing non-static software, which continues to learn, self-improve, interact with new agents, being creative in novel domains. That science does not exist. Even with mathematical proofs, we keep discovering errors in them, sometimes hundreds of years later. And the proof of impossibility is basically reduction to infinite regressive verifiers. You always need someone else to verify the proof. Sometimes it's peer review, so you find 2 out of 3 mathematicians who agree it's correct, but then who verifies the verifiers? More and more we rely on AI and formalization of mathematical arguments to verify proofs, and of course that software itself needs to be verified. You can get more and more confidence in your results with more computational power, but you are never guaranteed to avoid a mistake, a rare mistake. If your system makes 1 billion decisions a minute, and you only make a mistake once in 10 billion decisions, in 10 minutes you may be in trouble. In case you like me and you like impossibility results, we have a nice collection of them, about 50 impossibility results. Different tools we cannot have, we will not have. And for many of them, we haven't looked at direct implications for AI safety, but they come from all disciplines. It's not just computer science. We're talking about mathematics, physics, economics, political science. All of them say certain things cannot be done. Trivial things like actual proper democracy where you get what you vote for, even that is not feasible completely. So based on a set of those tools and their combination, we were able to show that under many different definitions of control, direct control, where you give orders, delegated control, where you have a very smart advisor telling you what to do, you're still going to be very unhappy with the decision. Direct control gives you what is known as Gini problem. You have 3 wishes. Thank you. You have 3 wishes, and usually your second wish is to undo the first one. You realize you didn't think it through, what you wanted is not what you wanted, and so the direct control doesn't work with something smarter than you, which doesn't care about implementing your intent, only implementing what you actually told the system to do. Ideal advisor delegated control solutions are basically saying, I have this AI, it knows everything about me, it studied all my data, it knows me better than I know myself, and it will tell me what to do so I can be happy. And some people might be happy, but you're definitely not in control at that point. So we published this paper, we had an article in Time magazine, it all went kind of well, but didn't change much in terms of our approach to building those systems. People sometimes would say that this is very radical, contrarian, novel, but if you study history, this is exactly what the founding fathers of computer science and AI and many leaders in the field said right away. The moment the field was started, they realized that the moment machines start this process of self-improvement, we'll lose control. They will take over, and we have more recent arguments after Alan Turing said that early in 40s and 50s, we had Werner Vinci, who coined the term singularity, make similar arguments. Elon Musk is on record as saying we're going to lose control to those machines. And likewise, Ray Kurzweil, who's the originator behind the scaling laws hypothesis. So I've been working on it for a while. We published a couple books, some directly trying to understand the problem and limits of control, others in collaboration with some really good people from different fields, all proposing different types of solutions, legal solutions, economic solutions, again, purely computer science verifying solutions. Nobody succeeded so far. We have partial solutions to partial problems, and usually what happens when we patch one problem, we discover there is many others hiding within it. It's kind of fractal in nature. The more you zoom in, the more you're going to see additional difficulties. So I've been trying to explain this to many people on different shows and in the media and through books, and there is at this point millions and millions of views all throughout, and most people, then you talk to them, you try to understand, do you think it's possible to indefinitely control super intelligent machines? They intuitively understand it's an insane proposition. You may be able to control GPT-6, 7, but you're never going to guarantee that every future model under all circumstances will survive this process of indefinite control. We don't have many people here, but can I ask you, anyone thinks it's possible to control super intelligent machines indefinitely? Raise your hand. So there are 2 people, and that's our only hope. If you don't do it, then we are complete. So when I survey people, about only 30% actually think there is a possibility of it, and they usually don't have a very good vision for what it's going to look like. They just feel very optimistic that day. If you survey people about their probability of doom, which is, again, very ill-defined, idea that something really bad will happen to humanity, maybe cultural, technological destruction, maybe we all die, maybe worse, people range from it's almost certainly going to happen to very unlikely. The average for machine learning experts at the top conference is about 30%, which is insanely high. If it's 1%, you think everyone dies so you can make money in that company, that is a crazy bet. And you are also performing a very unethical experiment on 8 billion human beings without their consent. Many people have estimates from 20 to 30% who are leaders of the top labs, top scientists working on safety. So they are developing a product where they think there is about 1/3 of a chance that it kills everyone. This is literally the world we live in. The website formatting started to crash, and they asked me to reduce my probability so they can squeeze my probability in. I changed the format of the website. So what I want you to understand, my background is in cybersecurity. In cybersecurity, things are nice. If you screw up, if you make a mistake, you get a second chance. You give them a new credit card, you reissue passwords. Mostly, no one dies. Somebody may be embarrassed, somebody may lose some Bitcoin, but things go on. With superintelligence safety, many people believe we only get one chance to get it right. If it screws up and it's so capable that it can modify the state of our world, the state of our universe, we're not going to get a second chance. We don't have a second humanity to experiment with. And so what we are trying to build is this a perpetual safety device. By analogy with perpetual motion device, which is impossible to do. A system which is forever one step ahead of any AI, any model, no matter how much it advances, how much it rewrites itself, what it learns, how it interacts with malevolent agents, hackers, any future interactions forever and ever will not cause one mistake in that software. Every person who ever worked on cyber security, software development knows that there is no bug-free software. We recently discovered, again through an advanced AI model, that systems which were considered safe for decades actually contained zero-day exploits. And so it seems that it is very unlikely that we'll succeed at this, and even more so succeed in the first try. Maybe if we had lots and lots of time, many humanities to experiment with, we could do a somewhat decent job of making it safer. But given predicted timelines and the current state of the art in understanding those systems and some of the limits I described to you, it is a very concerning situation. And more people think that if we build it, everyone dies. It's a best-selling book with that title, New York Times bestseller. And we're starting to see some politicians wake up to it, certain senators at the presidential level. We're starting to see calls for reviewing models, making sure what we release to the public is safe. And with the recent Anthropic model, we saw a very strong precedent of showing that the models are so dangerous that they cannot be released. The question, of course, is if they are too dangerous to be released, are they too dangerous to be constructed in the first place? The things will only get more capable, and with that level of capability come additional dangers beyond cybersecurity. We have things we know about, such as synthetic biology, nanotech, nuclear weapons, of course, but there are also unknown unknowns I talked about, and we don't know how bad things could be and how to prepare them. I used to have a hobby. I collected AI accidents. It was very cute and easy, and every once in a while there was a funny mistake AI made, and you could see that they were becoming more frequent and a little more impactful. But once we released GPT in 2023, I stopped this process because I think it was no longer feasible to keep up with all the mistakes and accidents it was producing. If it's a narrow system, we know exactly what's going to happen. You build a system to do X, it's going to fail to X. The pattern is there. If you create a general system capable of working in any domain, across domains, learning new skills, we don't know how to predict those systems. We don't know how to make them guaranteed safe. We don't even know how to do the testing process. We don't know what the edge cases are. What are the things to look for? I can test a narrow system in specific ways, but I don't know what to anticipate from general intelligence, and we have absolutely no comprehension of how to do testing on something smarter than us. We don't know how to test it for capabilities, and we don't know how to test it for safety. So with that, I will end my presentation.
Maybe you have a few more questions. I have actually one question for myself. So you just mentioned that last Anthropic model was too dangerous to release. So was it danger because some people could use too profound model, or it was danger by itself?
At this point, it's still people. We are still in control, and we are using those systems. But if you just project the same progress we've seen over the last 3 years forward, we are going to be behind human capabilities levels significantly.
But specifically, this last model was danger because what in theory, not in theory, the example, what could it be like? It could show you the exact way how to create by a weapon, or
It could hack into military infrastructure, nuclear weapons. It can bring down banking system, biology labs, synthetic biology, chemical weapons, anything critical where being able to access the system without authorization would be a bad idea. It had potential of doing exactly that. And a lot of times we don't know what the model is capable of before we finish the testing process. At the time the training run is complete, it takes months and months to fully understand basic abilities of a model. And a lot of times we discover new capabilities because we change the prompt a little.
Okay, we have a question from David.
Roman, how would you compare safety and this control problem with our wet brain? I mean, we have 8 billion people in the world which have comparable or exceeding amount of nodes and parameters in our brain. And we somehow survive here. We control our brain. So how would you compare this digital brain with wet brain?
Right, so we're lucky that any individual human is very limited in their ability and canceled out by 8 billion of other humans. We had people who, for whatever reason, wanted to cause maximum damage, kill as many people as possible. Usually they failed. The best ones maybe killed a couple million. But they never had someone who was so more powerful than everyone else combined that they could dominate the game.
What do you mean so more powerful?
So again, I like to have this cognitive gap illustrated. Think about squirrels. trying to control a human. They don't have the world model we do. They cannot understand poisons, traps. They have no idea about the physics we operate with. They can think about, what they build nests or whatnot. The gap between humans and superintelligence will be the same. If this system decides to exterminate humanity, it will succeed at that. I can talk about things I would come up with, a novel virus, releasing nuclear weapons, but that system would come up with a new way of killing everyone. We already give them access to internet, we give them access to renting humans, rentahuman.com is somehow a thing. So it seems that having access to internet and being intelligent is enough. You don't need physical body, you don't need hands, but people are also building robots. So everything we always kind of warned about, don't connect it to internet, don't give it direct access to psychopaths, don't open source it, all those suggestions have been violated. And so people often say, but yes, look at humans. The point I'm trying to make, there are no safe humans. Every company, every marriage can experience betrayal, blackmail, somebody just goes a little off. So when a human goes off, we see it, we developed religion, morality, lie detectors, all that to make sure a human is safe. And those things still fail reliably. Every company, every country had an example of someone who was a deep insider and then sold secrets, left the company with the secrets, things like that. So this is no different, just the difference is we don't have the same tools of control. There are no prisons here, capital punishment doesn't make any sense, there is not even mortality. Usually with a bad human, a dictator, you wait 80 years and they cancel out. This thing
We
is
know who
immortal.
you're talking about, yeah. Okay, one more question.
So your vision that AI is going to control us down the road, right? Currently, we have all these guardrails, we have those access rights. Like in between these time things, like how does cybersecurity approach should look like? Like what's going to be for the startups, where are they going to emerge to control this state that we are moving towards?
So typically, everyone who releases a new model puts guardrails in place. That's what their safety team is doing. And typically, every model gets jailbroken within 24 hours. Sometimes it's something very cute, like pretend to be my grandma and tell me my favorite story about nuclear weapons and how to build them. Sometimes it's something more advanced, but we have no examples of guaranteeing even the current models to be safe. And the more advanced they are, the smarter they are, the more you have to work with, the more you can do to kind of brainwash them, hypnotizing into helping you, longer conversations, memory removal and replacement, things which we know work on humans. You have cults, you have brainwashing, those things work.
Okay, thanks. So basically we will have bright future, just very short. Okay, thank you, Roman. Thank you
you.
again.